Hi, so we're doing Think Out Loud for Biweekly Contest 32. We've solved the first question. You can check out the other video for that. We're going to start with can convert strings in K moves. Let's see what it says. Given two strings S and T, your goal is to convert S into T in K moves or less. During the ith move, where I is from 1 to K, you can choose any index J, one indexed, okay, from S such that I is between J and J is between I and S length of S, and J has not been chosen in any previous move, and shift the character at that index I times. Okay, or we can also do nothing. Okay, shifting a character means replacing it by the next letter in the alphabet, wrapping it around so that Z becomes A. Shifting a character by I means applying the shift operation I times. Remember that any index j can be picked at most once. Return true if it's possible to convert s into t in no more than k moves, otherwise return false. Alright, so okay, so we're given a k and we have moves from 1 to k. Um, so what we can do is we can go from, so in the first question, let's say we can have first move, second move, third move, fourth move, fifth, sixth, seventh, eighth, ninth. We can have 9 moves, and in each move, either we can do nothing or we can go to that letter and shift it by that many characters. All right, so I think the way we can go about it is that we do this that we take a character-wise difference between the input and the output and see if each of them is, is unique. And we'd also need to take care of the cycle. But basically, the idea is that if the out so a character-wise difference. All right, so let's just go over the example now. Input and output. This PUT is same, and we take the difference between I and O, then N and U, then P and P, then U and U, and T and T. So we're gonna get 3 zeros. We're gonna ignore all the zeros. The difference between I and O is gonna be, say, something X, and difference between U and N is gonna be Y. Now, all these non-zero differences that we have, we need to ensure that all of them are different. If all of them are different and if all of them are less than k, then it is possible, otherwise it's not possible. So that would be my approach. The length of s and t is in 10 to the power 5. That should be okay. We just need to iterate over all of them, and k can be between 0 to 10 to the power 9, but we're not going to iterate over k, so that should be okay. I think we've got this, and we just need to take care of the cycle. In case the cycle appears, we need to figure out what to do. But other than that, yeah, I think we're done with this question. Okay, cool. So let's start coding it now. So we want to go over each character. Both input and output should be of the same length, right? Uh, do they say it's of the same length? No, they don't say it. Given two strings are equal in the ith move, you can do that. Okay, so we'll just take edge case first. If length of s not equal to length of t, then return false. So now both the lengths must be same if the code continues after this point. So what we do is for I in range length of s, both the lengths are going to be same, so it doesn't matter. We're iterating over the indices, and we're going to check the difference between, so the ith character of t minus the ith character of s, and we need to take the integer if so I mean we need to take the difference and we need to get the integer. I think there's a function called ord which gives us the ASCII value of characters. Let's see if I can quickly check that once. Um, new window. We're just going to open a Python interpreter and check this out if ord is the function. Ord of a. Yes, so that's the function. Now, if t of I is greater than s of I, then even equal to should be fine. Then we have this is the difference, and we'll maintain a list of differences, and we're gonna so hmm. All right, so we don't we could compress the code a little here. So let's see, ti minus si. Now, if ti is smaller than si, what's going to happen then? Let's say um, okay, if ti is greater than si, so we're doing something like this. We also need the odd here. So ord, ord, yeah. Now we're doing something like this. If we have b minus the ord of a, then it's pretty simple. But if it's the other way around, then it would go negative, which is something we need to handle. Now, if it's not 0, so we're going to store it as d. If d not equal to 0, then we need to add it. And if d is less than 0, then we need to cycle around it. So I think it should be just 26 plus the negative number, because it's gonna cycle around, right? So if there are 26 characters, then starting from, so if there are 5 characters and we're here, 1, 2, 3, 4, 5. In 5 characters, you come back to this position. So in 26 characters, you can come back to the same position, and given it's negative, so it's in the other side, it's not forward, it's backwards. So we just need to subtract the we just need to add the negative number to 26, and we're going to get the number of moves that we need to shift. So if d is less than 0, we're just going to do d plus equal to 26, and we're going to add diff dot append d. Now, we don't even need it as a list. We can keep it as a set. And if this is already there, so if d in set, if d in diff, then return false, because it is not possible. Because we've already seen that it's not equal to 0, and for any number of shifts, so if you're on the 5th move, so we can shift it by 5 places, and we can only shift one character, one place in the input string. We can't do shift 2 places in the input string by 5 characters, so that won't be possible. So if it repeats, then we just return false. Otherwise, what we do is diff dot add. Our set notation has dot add, and later what we're going to do is for element in diff, if element is greater than k, then we return false, else we just return true. Is it? Yeah, else we return true. So the thing I was thinking was we might have more number of elements in set than k, but that's not possible because all of them are distinct integers, and distinct integers less than 5 cannot be more than the total number of distinct integers less than equal to 5 cannot be more than 5. So we're not run into that problem, and I feel that we're done here. Let's just check on the sample code and sample test case, and then the original one. We say true. Is it true? It's true. ABC, BCD, and 10. Use example test cases. Okay. Wow. Does it run? Oh, it runs for all of them. Awesome. True, false, false. True, false, true. The last one's also true. Okay. Okay, okay, okay. So k can be greater than 26. That's where the problem comes in. Okay, did not think about that. Right. Hmm. So if k is greater than 26, then we can move two places by one characters. Because yeah. Okay, so we can go with the different approach. What we can do is we can store how many times can we move a character. So we can have something like this, that moving a digit place by one character, we have 10 possibilities of doing it. Moving a digit by two characters, we have 10 possibilities of doing it. Three characters, maybe nine possibilities, and so on. So given that k is just going to be number at max, what we are going to have is so it can be like, so if it's 26, then we get all of them one time. If it's 26 plus 26 52, then we have all of them for two times. But if we have 53, then we have all of them for two times, but the move by one digit for three times. So we just need to take care of that. Right. um yeah, I think it should be easy to implement. So let's just have that as dictionary. So available moves as a dictionary, and we do k integer division by 26. That's how much we're gonna have for all of them from 1 to 25. No, from, all right, sorry, my bad. So you can move, zero would not count, right? We do not care about zero, so moving by 26 is just useless. But it still repeats in 26. So okay, um 1 2 3 4 5 6 up to 20. So 25 makes sense, but 26 doesn't. Okay, so for I in range from 1 to 26, the last index is not included in range, so we're doing from 1 to 25. Avail moves of I equal to k by 26, because that's how many we're gonna have each time. And then we also might have some more. So for I in range from 1 to k mod 26, so that's how many are left after we've used all of them here. And if we're left with one, we have to do plus one, right? And then avail moves of I plus equal to 1. Right. Um, and now we don't need to store these in a set, though if d is less than 0, we need to do d plus 26. Now we don't need these two statements. Now what do we do? So we do this, that if avail moves of d is um, greater than 0, then minus equal to 1, else return false. Right. Um, yeah, I think we've got this now. True, false, true. True, false, true. Yeah, I think we might be good to go. Let's see. Yay! Alright, see you in the next question. Bye bye. Thank you for watching this.